turns into. The x minus 2 turns into what? X plus 2 as a factor, right? That's going to be one of the factors that's going to be here. And then this was the part that caused some confusion. The 1 and the minus 9 here is going to tell you the other factor. You have the minus 9 here, and then the 1 is in front of x, so just 1x.
So the negative 9, that's your coefficient, right?
That's,
That's what,
I mean, technically.
So 0 is really nothing. We can cancel him out. Negative 9 would be
yeah.
a coefficient, and then 1 would be considered x.
1 is the number in front of a variable is called the coefficient. So this 1 is the coefficient of x.
Gotcha.
So I don't want to really call 9 a coefficient, although technically it is because there's an x to the 0 here, but then we start, yeah.
Okay, I see.
So, all right, now we go back over here now, right? We go back over here. So I'm going to come over here and do this. Do not forget what we did in the very first step, right? What did we do? We pulled x to the fourth out. So we're going to rewrite that x to the fourth. Then this in red now becomes x plus 2 times x minus 9, and then equals 0. So see, I'm coming back and finishing up what I was in the middle of doing. When I went to go factor, that was like scratch work on the side, so I could break that down. Now that you've got it completely factored, questions? You all right? Sure? Okay. Now that you've got it factored, you set each factor equal to 0. So set x to the fourth, set it equal to 0. X plus 2, set that equal to 0. X minus 9, set that equal to 0. Yeah, so the first one, the only number that you can raise to the fourth power and get 0 is 0 itself. Here, subtract 2 on both sides, you get x is negative 2. And here, add 9 to both sides, you get x is 9.
Okay.
We're almost done. We're almost done. So what we did, just to recap, very first step, we figured out the end behavior, right? What it did off that table. We figured that it was both sides up, right? The second step was to find the x-intercepts, which we just found. But this is not enough information to graph. The next thing that we need in order to get a final picture is to know whether or not we bounce or cross at these x-intercepts. Do we bounce or cross? And how do we determine at each one of these whether or not you bounce or cross? What do you look at?
Up top. That's your
Up here, and you look at the exponent here, right? The power. This 0 came from this, right?
Yes.
So you go to that power and you look at it, and what you're looking for is even or odd. Even. If it's even, which it is, right? It's even, we will do what? Bounce. Bounce. If it's odd, okay, so here this negative 2 came from here. What's the power on this?
Yeah, sorry. 1.
It's 1, right?
Yeah.
That's odd. So we will cross through here. And then again, this 9 came from here. This is a 1. That's odd. And that means I'm going to cross here. What you do not do, common mistake, what you do not do to determine bounce and cross, you do not look at this number itself. This number is not what you're looking at. You're looking at the power of the factor. That's what determines the bounce and cross. All right, let's graph. So I draw a number line. Draw my x and my y. I'm going to plot my x-intercepts. Negative 2, somewhere around there. 0. And 9 is over here. Doesn't have to be perfect. Just make sure it's in the proper order, right? Don't get the numbers backwards. Once I have the dots, anyone remember what I do next? What I should draw?
Your arrows.
Your arrows, the end behavior. Do that step next. In both sides, we're doing what?
We're going up.
Up. So over here,
Look at our sketch.
go up like this,
Yeah.
and over here it goes up like this. I know that much. And now I need to somehow connect these arrows together with a smooth curve, crossing or bouncing wherever I need to. Yes?
For some reason, this is what messes me up.
This part?
Yes.
Okay, all right.
I don't know why, but I don't know.
This line right here, right, as I draw this line, I'm either going to go through the line, which is crossing it, or I'm going to bounce off of it like a ball would bounce off
So
something,
cross is
right?
through.
Cross goes through. All right?
That makes sense.
So what's supposed to happen at -2? I'm supposed to cross. So when I draw this, I'm going to come through here and I'm going to come down a little bit. Let's just do that. I'll just cross through. Right there. Do you agree I've crossed through?
Okay.
Right? But now I need to continue with the smooth curve, right? No jagged edges, a smooth curve. I've got to get back to 0, don't I? I've got to get to this point. And when I get to 0, what am I going to do? I'm going to bounce. So that means when I go here, I'm not going to cross through. I'm just going to kind of touch it and come back. See?
Okay.
Touch or bounce, however you want to look at it.
Okay, touch.
Touch. I think I asked y'all,
Yeah,
do you prefer touch or bounce? And someone over there said bounce, but
I feel like
everyone's
touch,
different.
bounce makes it, yeah, everyone's different.
Yeah, everyone's different. So
You touch it.
touch, just touch the axis, come back down, and then now I need to get from that point 0 to 9, right?
Yeah.
And smooth and curved. And when I get to 9, I have to what? Cross through, which kind of makes sense because I have to get here, don't I? So I'm just going to kind of go through here, and I'm going to cross through and then connect these together,
Okay.
and that's it.
That's all I needed was the touch.
Yeah. Yes.
I just, one thing like kind of messed me up, the X4. I don't know why
The
that's
GFC.
on the outside.
We pulled that out in the very beginning, right? The GCF. When we were looking at, this was the second step, this point right here. Right? At that point right there, we were trying to find the GCF, greatest common factor, which is, well, first you look at numbers. Are there any numbers that go into all of these numbers? No. Okay, so how about variables? Do they all have an X?
Yes.
Do they all have 2 X's?
Yeah.
Do they all have 3 X's?
Yes.
4?
No.
Do,
Oh, yes.
do they all have 5 X's? No. 4 is the most they all have, right? So I pull X to the 4th away. If I take 4 X's from here, how many X's do I have left? I have 2 of them, right? X squared. Minus 7. I took 4 away. How many X's do I have? Just 1. Minus 18. I took 4 away. How many do I have left? None. So I'm done. Right? So that's where the X to the 4th came out, that GCF step. Good. Okay, so we went through the whole thing, so that's going to be on the test then, for sure. All right, moving on. I think you're going to find the rest, there's not a whole lot left. It's about four or 5 problems. Yeah, so the next one I think is going to be a good problem for you because you all did well on this problem. This is the simple interest problem where you put money in the bank for a certain amount of time, figure out how much is there at the end, right? So let's say you invest $12,000 at 6.85% for 6 years. How much do you have? How much is there? I'm being quick here because time. I mean, how much is there? Like, how much after 6 years would you have, right? So what formula do you need for this? PERT, shampoo, right? A equals P times E to the RT. You need that formula. And, oh, that's not right. It would have gone. You got it? Where'd it go? Can you get it? I just don't want you to stand up and then slip and then break your arm and tell me you can't take the final. It's all my fault.
You're in the pyramid.
Yeah.
You.
And then sue me, right? Yeah, sue me. Thanks. Appreciate that. But how about watch your step? How about watch where you're going? All right. What are we doing here? Just plugging in, right? This is the easier of the 2 problems that you're going to have that involve PERT. This is the easier of the 2 because you just plug in, get your calculator, and you're done. So what is the 12,000? P. That's your P. What is this? Interest rate. But remember, we'll have to convert it from a percentage to a decimal, right? And then this is T, right? 6 years. So the amount will be 12,000 e to the 0.0685 times 6. How do you convert a percentage to a decimal? Move decimal 2 places to the left. That's why I have a 0 in front of that 685. If you forget that step, it's going to be wrong, and you'll know because your answer will be huge. You'll have this huge number. Our answer should not be like $2 million, all right? Let's see what happens. So I'm going to trust now that you can put this into your calculator, and I'm going to do mine and see what I get, and see if you get the same thing. $18,099.90, somewhere around there. You can be off a little bit. It's okay if you're off. You just can't be like, oh, $1.2 million, right?
What do you have?
$18,099.90. Did anybody watch that Squid Game thing challenge? Anyone? No? No? Netflix? No? Okay. It just came out, I guess, recently.
Some of the people are suing Netflix for it.
Oh, they are?
Yeah. Apparently some people got like really bad with
Oh, hurt? Oh, really?
Don't they like sign like
Yeah,
the
probably
way
sign
they're
them
saying?
like their life away in the beginning.
Like they-
No, the winner won like $4.3 million or something. I'm just curious if anyone watched it. All right, got it? Good? Yes? Okay, now next problem is going to be something like this. How about you invest $12,000 into a simple interest? Oh, no, let me start over. You invest $12,000 at 6.85% again. How long until you triple your money? Will you still be alive? Same formula, right? Except now I've given you what? P, right? This is the amount you put in. I've given you R still. You have to convert to a decimal. I'm asking how long, right? So time is what we're solving for, and tripling our money, right? That means that the amount at the end needs to be 3 times bigger than that. So when we put this into our formula, the right side is 12,000 e to the 0.0685, but we don't know the time, right? We actually do not know the time this time. But do we know how much we are supposed to have at the end?
Yeah.
What is it?
36,000.
36,000. All you do there is just multiply your 12,000 times 3, right? Tripling your money means 3 times as much. 3 times 12,000 is 36,000.
We're gonna do the log.
We are going to wind up using a log, yes. But before you can use the log, you have to get this by itself. And to do that,
12 by the 36.
other way around. You're dividing 36,000 by 12,000. I think what you're doing is right. The way you said it is not. You're taking 36,000 dividing by 12, which should just be 3, right? Because that's how we got it. This goes away. You get 3 equals e to the 0.0685t. And who wants to explain the next step? Anyone want to explain to everyone what you're doing? Someone who understands this or thinks they understand it, explain what you're going to do now.
LM.
Now it shows how you write it. So you do log over e at the bottom.
Okay, so you're going to write log with e down here,
Yeah.
and then
you're gonna do 3 because you're
3.
an exponent of 0.068.
.0685 t, right? Is this what you were going to say?
Yeah.
Okay, so you're writing the log base e, because that's your base over here. Then the 3's here, and this is here. Now, the reason you know it's this is you can check to make sure you wrote it right by doing that loop, right? And looking. If you take the e and you raise it to this, does that equal 3? Is that what you have written here? E raised to that equals 3? Is that what you have? E raised to that equals 3? Okay, so we've written this correctly. But what is log base e of 3 really mean to us for our calculators? Natural log, ln3. So ln of 3 equals 0.0685t. And figure out what natural log of 3 is on your calculator.
1.098.
What is it?
1.098.
1.098 on my calculator, or your calculator. And then 0.0685t. Final step, solving for t, so divide both sides by a 0.0685. It's going to be big. Well, it's years. What is it?
16.0.
I mean, not like you won't be dead, but 16 years?
Yeah.
16 point what?
0.
03? Okay, about, and again, this is an approximate, years.
Would we still get it right if we did like 1.9 or 1.09?
Yes.
Because I got a different answer to.
How different? What'd you get?
15.
Yeah, that's fine.
So it's okay.
Yeah. Yeah, we're all gonna be a little different on this.
I didn't know if you were gonna grade it and say numbers, be like, no.
No, I'll be looking at your work, and if I see your work's right, I'll know you just rounded,
As long as it's
different than
ballpark.
someone else did. Yeah, don't round that up to 20, you know?
Or you could round it like 1.1. Like that's.
If you want to be safe, just use more decimals when you're doing your computations. But again, I'm just looking to see that you're doing the method right. For me, the biggest thing is, can you implement the log, right? Do you know how to implement the log? Do you know how to make the loop and create the equation? Because once you get here, it's just a matter of calculator. Okay, good. Now, in this problem, I said triple your money, right? What if instead of saying triple your money, I said something like, how long until you have, I don't know, $31,000?
That would be your A then.
Then that would be, yeah, the other side of the equation. Instead of having to figure out, 32,000 or what was it, 36,000, you would just know that number, right? So that would be less work, wouldn't it? Okay, next thing.
So are you thinking around like 10 questions?
What are we at right now?
We're at 9.
We're at 9, so this will be 10?
Yeah.
Okay. Yeah,
If we do another one.
yeah, so the one I'm about to do right now is 10?
Yep.
11,
Like 15?
11, 12 probably. I'm thinking 12. Keeping it short and sweet.
Perfect.
Yeah. All right, next one. Solve. Three x minus 4y equals 13. X plus y equals 9. All right, this is a system of linear equations.
These ones are so fun.
Yeah, and I showed you two different methods to do this. What's up?
That's the one where we multiply out.
You have choices here. The question you have to ask yourself when you see this is, are you going to do substitution or elimination? And I think most of us wanted elimination, right?
Yeah.
Well, I think most people like the elimination more. So if you're going to do elimination, you have to choose, are you going to eliminate the x's or the y's? And it's completely your call, like completely up to you.
Let's do that.
So you want to do x's? Do you care? Anyone care? X is okay?
Yeah.
All right, so if we're going to eliminate the x's, what I'm doing is I'm saying I need the 3x to cancel with this. when I add them. Right now, if I add them, I get 4x. So I'm going to be clever. I'm going to make this a negative 3x. That way, when I add them, they cancel. To do that, I have to multiply by negative 3 here, here, and here. The entire equation gets multiplied by negative 3, which creates the negative 3x, which will cancel with the 3x on the equation above, right?
Yep.
All right, so this becomes a new system. It's 3x minus 4y equals 13. And then the other one is negative 3x minus 3y equals negative 27. Biggest mistake I see students make is they mess up with the negative 3. They don't take it all the way through, or they'll take it through these two, but not that one. So make sure it goes through the entire equation, right? Now, if you did it right, if you add the 2 rows down, your x's go away. So make those go away. You get, okay, so these add up, they go away, right? What about our y's? What do our y's add up to be?
7.
Negative 7y. And then equals, these two add up to be negative 14?
Yeah.
Okay, negative 14. And now you can solve for y, can't you? Just divide both sides by negative 7. Y is 2, positive 2. Okay, so you've got one answer. You need one more. You know what y is. Now you need to go get x. And to get x, you can take that answer for y and plug it in. What's up? This step? Okay. So I can plug that answer into what? Where?
No, you have to plug it to the x. Or the y.
Into y, what, where?
In any equation.
Any equation I want. And I always suggest you pick the one that looks the nicest. And to me, I don't know about you, but this one right here looked pretty nice when we started, right? So I'm going to take that equation right there, x plus y equals 9, and I'm going to replace this y with 2. When I do that, I get x plus 2 equals 9. Subtract 2 on both sides, x is 7. And that's fine. If you just say what x and y are, that's fine. I think in class I asked you to write it as an ordered pair, like a point. 7, 2. And the reason I like you to write it as a point is because this is actually where 2 lines hit each other. Right? There's 2 linear equations, and it's 2 lines in the graph. That point is where the 2 graphs hit each other.
So
Now,
would you
yeah.
prefer us to do 7 too, or no?
I don't care. I really just want you to be able to get the answer here. Yeah. Now, I'm not going to give you, remember the mixture problems where you had like acid and stuff and it turned out to be an equation? I'm just going to make sure you can solve a system of equations. All right? Unless you want the mixture.
No, we don't want.
You sure?
Yes, we should.
Okay.
I feel like I had to like think really hard about them sometimes. I was like, dang, what is it?
Okay, well that was my next problem, so it can't be that. So that means we'll have just one more thing.
So it is 11.
Yeah, it's going to be, yeah, it'll be 11, well, I'm not saying it's going to be exactly, 11 to 12, questions. Ballpark, yeah. The last one is going to have to do with what we ended with last time, which is converting things, right? The dimensional analysis. It's a word problem, but oh my goodness.
Wasn't that also having to do with exponential growth and decay?
Which one?
The dimensional analysis?
No. You'll see. So something like this. Robert can mow 1.4 acres in 38 minutes. It's a riding mower. It's a big old fast riding mower. Okay. Robert can mow 1.4 acres of grass in 38 minutes. Okay. How long will it take him to mow 0.32 acres?
So you're gonna like do like the translating one? Cause you know, the last time we did it like to where it was like, instead of minutes, you do like seconds or something like that.
I don't think we'll need that here. That'll be the next one I do after this. There's one more problem I want to do after this. So, okay, so first things first. Robert can mow 1.4 acres in 38 minutes. That is the given information, right? So I'm going to write that down, and I can write it two different ways. 1.4 acres in 38 minutes. Or you can write it the other way around. What? 38 minutes, 1.4 acres. Now, this is where I confused all in class, so hopefully you're not still confused with this. I'm asking how long it's going to take, right, to do this much acreage of mowing. So I'm going to let X be the X minutes, right, is what I'm trying to find, over 0.32 acres. Okay, that right there is what I'm looking for. How many minutes does it take me to do that, right? But this must be equal to whichever one of these is the same thing with minutes on top and acres on the bottom. So 38 minutes on top, and then 1.4 acres on the bottom. And then how do you solve this? You can do a cross multiply. You can multiply 1.4 to x, and then this 0.32 to 38. So calculator, just in case. So when I do 1.4 to x, I get 1.4x. And when I do 38 times 0.32, I get 12.16. Hey, before I get an answer here, is it going to take me longer or less time to do this? I mean, it took me, for 1.4 acres, it took me 38 minutes. It should take me less time, right? Because this is less acreage. So my answer better be less than 38 minutes, right? Let's see what happens. Solve, divide by 1.4.
8.6 and 8.
8.6, yeah, 8.68. I would take that. That's fine. 8.68 minutes. That, to me, that makes sense. I hope it makes sense to you. Yeah. Good? Okay. Now look, this could be anything, right? I could say something like, I don't know. I mean, anything you can think of. Horses? What?
Oh, I don't know. I was thinking
Robert
we have this many
Robert
horses.
can bathe
can
3
run,
horses
he
per
can
hour.
jump.
Yeah, I mean anything you can think of. I can fail 5 students in one day. No, I don't fail students.
You can make
Students don't reach their goal. That's what happens. Okay, yeah? Can I move on to the last type? Okay, the last type has to do with converting units. So I would like for everyone here to be able to do something like this. How about if I tell you to convert 300 milligrams per hour into grams per minute. Grams per minute. Now, to do this problem, I also have to give you some additional information. Perhaps. I do expect everyone in here to know the relationship between minutes and hours, right? That there are 60 minutes in an hour, right? Like that I would expect you to know. But I don't necessarily expect you to know how many milligrams there are in a gram. I won't expect that, okay? Some of you know, some of you don't. So I would provide that to you. So I would provide something like this on the side of this problem, something like a table where I would have some information. And one of the things I would have written in this table would be something like this. 1,000 milligrams is a gram. So this gram, I put grams here, but technically all I have to do is put G for grams. Something like that. So to do this problem, it's not like the mowing the grass problem. What you do is you start with what you're given. Okay, we write 300 milligrams over 1 hour. And then I'm not going to set up an equals. I'm going to start multiplying this by things to make the units that I want appear and the units that I don't want to disappear. So let's start with the hour first, because I think that's the easier one. I'm going to multiply this by something here where I can make the hour go away and make minutes appear. So I need the hours on top, that way it cancels, and then I need minutes on the bottom. And how many minutes did we say were in an hour? 60. So I put 60 minutes in 1 hour. See how that works? I think if you look at the previous problem, the way you can distinguish the two is because in the previous problem I told you like Robert could mow a certain amount in a certain amount of time, and then I asked how long does it take to do this? That's not, this is just saying, hey, take that and convert it. That's all we're doing, right? So there's a way to distinguish the two problems. All right, so I do that, and that I'm just going to leave it like that for now. Now let me try and take care of the next unit, the milligrams, right? I want that to become what? Grams. So I want milligrams to go away. I must put milligrams on the bottom so that it cancels with the milligrams on the top. And grams will have to be on top. And it was what, 1,000 milligrams in 1 gram. And if I do that, look at everything that goes away. The hours go away, right? And the milligrams go away. And now you just multiply the numbers across the top.